name is Caden, and this is GeoTrainer, a live geography training app um, where a multi-agent system looks at a street-level photo and figures out what country it's in. The same way a human GeoGuessr player would, by like reading signs, architecture, plants, road markings, etc. It's live in production right now, and I've built the whole stack myself, the product, the agents, the infrastructure, all by myself. So let's get started. Basically, if you've ever played GeoGuessr, it's kind of similar to that, in which you guess countries and you go across the world, figuring out, okay, where are we? So how is it different? Well, it employs a multi-agent system to help you train for GeoGuessr. So you don't have to go and create a GeoGuessr account and pay for it. So let's go test it out. Let's go to Vision Agent. And as we wait for the agent to guess its prediction, let's go and see what the agent does. Now, basically, whenever we call the agent, there is a supervisor agent. And in the supervisor agent, it has a list of tools it can access. But we have enforced a couple of them to happen through our harness. Basically, the supervisor agent will first call a vision extraction tool, which will take all the important items that are visible in the picture, and it will essentially take them and then format them in a JSON file that is pydantically enforced. And then it will pass it along to a sub agent, which it creates. So there we have a multitude of sub agent, each with their own specific retrieval tools. And it will pass all this information to the sub agent. And the sub agent, with the extracted information, will go and search up in our database. So, for example, if our vision extraction tool finds a bollard, then this it would, and let's say that it was outside, we would have probably a rural sub agent be chosen, and it will go and look at its rural tools, and it'll find, okay, bollard descriptions in our database. So it will go and use the bollard tools to grab all of the bollards of the countries, and it will say, okay, this description matches with Nigeria, for example. So we must be, I think we're in Nigeria, and it will compile all of these, retrievals together to make its best informed guess, and pass it back to the supervisor agent, which will then format it to emit a prediction. So let's see if it's finished in Langsmith. Yep. Basically, that is the structure. We have a to-do list to enforce our status and for like logging things. But in this case, it shows our rural specialist, given that we are in a rural area in our picture. And it will have emitted its prediction by now. And as you can see, it predicts a bunch of different stuff. It sees a bunch of trees, sees a driving side, finds a pole, I believe. But it says that this center red line matches with Mexico. And let's say we choose Mexico. It is correct. So this is supposed to mainly use to help train people on how to play GeoGuessr. Aside from that, every run is traced end to end in Langsmith. You can see here, and you can see exactly which tools fired in which order, which is how future debugging and guessing will work. And right now, this system is around 87% accurate in a holdout test dataset on Gemini Free Flash, which is around 7% better than the Gemini Flash baseline and within 8% of Opus 4.8. Though I am working to improve that constantly. It is backed by 175 Python tests and 30 plus node tests and playwright tests. And obviously, this is hosted online through a Dockerized VPS using MongoDB for our tool databases, and Caddy for our rate limiting and HTTPS service. So yeah, that's this is GeoTrainer. It's a real product with real multi-agent orchestration and cost testing and deployment guardrails to run it safe in production. Code's linked below.